All right, so we're continuing with solving linear inequalities, and everything that we talked about before still applies here, except now we're kind of looking at more of that multi-step. So before it was more the one step and the two step, now it's that multi-step. But remember, when we're solving these inequalities, we have to be careful. If you multiply or divide by a negative to both sides, flip the inequality symbol, okay? So just like in the last video, it's the same thing, but now we're looking at multi-step. Okay, so let's go ahead and solve these, and I'm going to write it underneath here. Okay, so just like a multi-step equation, if this guy were an equal sign, what would you guys do first? Well, we would check for the distributive property, right? Is there any distributive property? No. Then step number 2 was always check to see if we can combine like terms. Well, notice variables with variables, right? I can combine like terms. So we have 5 minus 8. That's different sign. What do? Subtract and keep the sign of the larger value. In this case, 8 is bigger and it's negative. So what's 8 minus 5? 3. And we keep the variable. And just like we said, 8 is bigger and it's negative, so this would be negative 3. So we get a negative 3 is less than 24. Okay? Now, we have multiplication between the negative 3 and n. How do I undo multiplication? Divide by a negative 3 to both sides. My inverses cancel out and I get n. What's 24 divided by 3? 8. Now, positive divided by a negative? Negative. However, did we divide, notice, did we divide by a negative to both sides? Yes. What does that mean we do with our inequality symbol? We flip it, right? So we flip the inequality symbol and we get n is greater than a negative 8. Okay, so just like in the last video, remember we have to graph these. Now, if it's greater than and less than, that was not inclusive. That means we do not include this number. When it's not inclusive, do we use an open circle or a closed dot? Open circle. So we have an open circle at 8. Then we have to decide which way to shade our graph. Remember, we can always go in the direction of the inequality as long as the variable is on the left, which it is here. So this is telling us we're going to shade this way, right? That's one way to approach it, but this is also saying, if we think about it in this sense, all the numbers bigger than a negative 8. Well, what numbers are bigger than a negative 8? Negative 7. Well, maybe. Negative 7. Negative 6, negative 5, and so on, right? So just like that symbol said, we're shading to the right, okay? Number 3 here. Let's work on this guy. We have 92 is greater than or equal to 4 plus 8 times 1 plus 5x. Again, we're going to work this just like a multi-step. What do we always check for first? The distributive property, right? So we're going to distribute this 8 to each term. These guys stay the same. Okay, so what's a positive 8 times 1? 8, right? Now, since it's a positive, we're going to have this plus symbol in between there. Then we have 8 times 5x. What's 8 times 5? 40, right? So we get a positive 40x. Okay. Step number 2, always check to see if you can combine like terms. Are there any like terms I can combine? Yes, numbers with numbers, right? We can put these two together. So I have 92 is greater than or equal to, what's 4 plus 8? 12, okay, plus 40x. Now, whoops, forgot my x. Now, in this situation, what does this remind you of? What does it look like? Well, it looks like a two-step, right? So we're going to solve this just like we would a two-step. I have a positive 12. How do we move it over? Subtract 12 from both sides. Inverses cancel. Subtracting here, we get 80, correct? So we get 80 is greater than or equal to 40x. Now, what's happening between the 40 and the x? Multiplication, right? How do you undo multiplication? Divide both sides by 40. Okay? Inverses cancel. Now, if you don't know what 80 divided by 4 is, here's a quick, easy way to think of it. Cancel out your zeros. What's 8 divided by 4? 2. So 80 divided by 40 is 2. Now, we could use this. However, remember, it's easier to graph if we keep the variable on the left, right? So if I reverse everything, if I flip everything, that's going to get me with the variable on the left. So let's put x on this side, 2 on this side. Then what happens to our inequality symbol? It flips, right? Okay, so if we flip everything, Then we have the variable on the left, but we're still saying that x is smaller. So this says x is less than or equal to 2. Okay? So if it's less than or equal to, does that include 2? Yeah, that means this number could equal 2, right? So are we going to use an open circle or a closed dot? Closed dot at 2. And again, we could follow the direction of the inequality symbol. This says shade to the left. But just so we understand, this says all the numbers smaller than 2 or equal to 2. Okay? What numbers are smaller than 2? Well, 1, 0, -1, and so on, right? So we're shading to the left. Okay? 2 more examples here. We have 27 is greater than 8 times the -1 plus 5k minus 4k plus 1. Okay? So step number 1, what do we always do? Apply the distributive property. So I have 27, that stays the same, is greater than 8 times the -1, -8. Positive times the negative makes a -8. 8 times 5k, 8 times 5 is 40, and then we also have our k, our variable, 40k. Now this one might be a little bit trickier over here because all we see is a minus sign, right? Well, remember, if we don't see it, we can always assume or treat this like it's a 1. So this is really a -1 times this guy. Okay, so let's distribute a -1 through. So this is a -1 times 4k. What's a negative times a positive? Negative, so we have minus 4k. Then we have a -1 times 1. Well, what's a negative times a positive? Negative, and 1 times 1 is 1. So now, after we distribute, what do we always check for next? Combine like terms. Well, notice I can do numbers with numbers, right? So we have 27 is greater than a -8 and a -1. Is that same sign or different sign? Same sign, so we add and keep the sign, right? 8 plus 1 is 9, and they're both negative. Are there any other like terms there? Yeah, variables with variables. Different sign, what do? Subtract. 40 minus 4 is what? 36, and since 40 is bigger and it's positive, we get plus 36k. Okay? Well, now we're just in a 2-step, right? How do I solve this for a 2-step? Well, we have to do the opposite of a -9, which is +9 to both sides. Inverses cancel. We have 27 plus 9. What am I going to get? 36. Okay, or you can think of it as 9 plus 7 is 16. Carry the 1, and we get our 3. So we have 36 is greater than a positive 36. We don't have to put the plus. We understand it's positive. Okay. Well, this is multiplication. How do we undo it? Divide by 36 to both sides. Inverses cancel, and we get 1 is greater than k. Or another way to think of it is k is less than 1. Well, again, it's easier if we keep the variable on the left, so let's flip everything, put this on the left and this on the right. What changes with our inequality symbol then? It flips. So this guy is now facing this way. So this says all the numbers smaller or less than 1. Does that include 1? No. Okay, so are we going to use an open circle or a closed dot? Open circle at 1, and all the numbers smaller than 1 are 0, -1, -2, and so on. Again, notice it's facing the same direction as this guy here. Okay, last one we're going to work on here. So in this example, we have a -3 times 1 minus 3x. This one's got a lot going on for it. 3 times 1 plus 4x is greater than or equal to 6 plus x plus 7x minus 6. Now you might be thinking, oh my gosh, there's so much going on. Remember, follow each step. What is step number 1? Apply the distributive property. So don't worry about anything else until we take care of that. So we have a -3 times 1. What's a -3 times 1? Negative and a positive make negative. 3 times 1 is 3. What's a -3 times a -3x? Well, negative times a negative makes a positive, and 3 times 3 is 9. We also keep our variable, so we get 9x. Now, we have one more here. We have 3 times 1. Positive 3 times 1 is a positive 3. Don't forget to put the plus sign because we're adding this together. Then we have 3 times 4x. 3 times 4 is 12, and then we keep our x. And now we've applied the distributive property. Okay, but notice we have variables on both sides now. Okay, that's not a problem. We still follow the same steps. What's step number 2? Combine like terms. Well, can I put numbers with numbers? Yeah, I can put numbers with numbers. But notice, this is a -3 and a +3. Different sign. What do? Subtract. Well, what's 3 minus 3? 0. So what happens to those two things? Well, you could put 0 plus, and then we can work on the x's. You could do that, but is it really necessary? No. So we can treat it like they canceled themselves out. Okay, so it's not necessary to write +0 right now. However, also notice we have variables with variables. We have 9 plus 12x, okay? So when I have 9 plus 12x, what is that guy going to be? Okay, well, you could write it out here if you're not quite sure. We have 11, carry the 1, and we get 21, right? So we get 21x when we combine like terms is greater than or equal to, then we have 6 plus x plus 7x minus 6. Do I have like terms on that side? Yeah, I have like terms on this side too, right? Well, notice the 6 and the minus 6, those guys cancel out again, okay? 6 minus 6 is 0. Well, I got rid of my numbers here. What else can I combine? Variables with variables. Now, remember, even though we don't see it, what is this guy in front of the x here? 1. So 1x plus 7x makes 8x, okay? Now, you might be saying, well, Mr. Pinksterhouse, that isn't making a whole lot of sense here. What's going on? I have x's on both sides. Don't worry about it. What was always step number 3? We had to pick a number side and a variable side, right? So step number 3 here, let's move all the x's here and then all the numbers here. So just follow along with me. If that's the case, this is a positive 8. How do I move it over? I subtract 8x from both sides. Okay. Now, is there going to be a number over here in this area? No. However, if I take 8x minus 8x, usually we just cancel it out, right? But in this case, what does it really mean if something cancels out? That means we have 0, nothing there, right? So for our number here, we're just going to put 0, okay? Then we have our 21 minus 8x. Well, what's 21 minus 8x? Well, we get 13, right? Now I have x's on one side, and notice I have this 0. So that 8x minus 8x, normally we would think cancel out, but it's giving us 0 here. What's 13 times x? Or, excuse me, we have 13 times x. So what's the opposite? Divide by 13 to both sides. Okay, so we get x is greater than or equal to 0 divided by 13, 0. Okay, so don't get hooked up on this. That's okay. Still move all your variables to one side and then have your numbers on the other side. Okay, so now I have x is greater than or equal to 0. Okay, that's inclusive. If it's inclusive, do we use an open circle or a closed dot? Closed dot. So we have a closed dot at 0. All the numbers that are bigger than 0 are to the right. Just the same thing here. Variables on the left, so we're going to the right. Okay.